mode of operation. The scan in, okay, is is what is going to get shift. Okay. So, this acts as a shift register. So, red is same as shift register. Whereas, the blue guy, right, will be parallel in parallel out register. So, when it is blue, so blue is parallel load operation. This is to inject the fault. So, when this is inject fault is high, 1 on this pin injects a fault. Okay. If I put a 0 on that pin, there is no fault. Okay. So, right now the fault that we have injected is y1 stuck at 1. So, y1 stuck at 1 fault has been injected. So, if I how to verify, first scan in, let us say 0 0 0, a good counter will have 0 0 1, but a faulty one counter will have 0 1 1, because there is a fault in the y 1. Okay. And then capture the output and then shift. So, during shifting we have to have scan enable equal to 1, during the capture scan enable equal to 0. Okay. So, this is the so called scan testing. So, this is what scan testing is. What is its advantage? See, it reduces the problem of, so scan testing advantages. Simplifies testing of sequential circuits. Okay. How it now testing of sequential circuits becomes a combinational testing problem. Okay. So, if I have PI, PO, next state, present state, state register. Okay. So, I can the tool, the ATPG tool will look at this part, okay, which is the combinational logic, and it already knows how to generate tests for the combinational logic. Okay. So, it will go ahead and generate test vectors for the combinational logic, and then we know what is the present state that must be shifted in. Okay. That will be shifted in using the shift register operation. So, that is the biggest advantage of scan testing. It removes all the headache that is associated with controllability and observability. So, it solves the controllability and observability problems. So, we cheat, we go into the serial shift mode or scan enable equal to 1, and that allows us to initialize anything we want into the state register. So, we have solved the controllability problem. Similarly, when we want to see what is inside the register, we simply shift out the contents. Okay. We do not have to worry about any. So, it is enough to have the serial in and serial out. Okay. So, what are the sort of penalty that we pay to achieve all this? We need scan enable, scan in and scan out, extra pins. Okay. Then all flops have been transformed to scan flops. What is a scan flop? This one is my D and Q. Now, I have a multiplexer sitting in front. So, there is an extra area. Okay. So, some extra area due to mux. That may not be such a big deal today, because our chips have a lot of gates. Okay. So, having a few extra multiplexers may not be a big deal. But what happens is there is a penalty of the gate delay. See, now originally this PI used to go directly to the D input. Okay, this is D input. Now, there is a gate delay. So, there is an extra delay due to multiplex. Okay, that will cause you to slow down. Okay, the circuit operation will get slowed down. Then some extra power. So, the multiplexers will dissipate power. Okay. Then routing is a problem, right? That scan, we had to go from one flop to the other flop. See, if there are flops like this, so this is your chip. In your chip, the flops are all over the place like this. So, if I have decided to connect them in this fashion, then I had to take the output of this and connect it to the scan input of this. Okay. and then it has to go here and then maybe here and maybe here. These wires are extra, they were not there in the original design. Okay. So, we have extra routing, okay, and that causes some, it is a headache. Okay. So, and then finally, slow testing. Okay. It takes us n clock cycles, where n is the number of flip flops, plus 1 capture and then another n to shift out. Okay. So, the testing proceeds like this. So, the first test vector shift in the present state, then capture next state. Then shift out the next state. Okay. So, this is test vector number 1. Test vector number 2, you could start from here and say, look, I will start the shift operation here, etc. But you can be smart. Okay. You can say, look, when I am shifting out the next state, I might as well shift in the previous state. Then capture, shift out in S. So, this is sometimes called as pipelining, little bit of intelligent way of handling things. Okay. The third one, test vector number 3, will shift in present state, capture and then shift out. So, if you had 3 vectors, then how many clock cycles will you do? N plus 1 plus n plus 1 plus n plus 1 plus n, right. So, it will take 1, 2, 3, 4, 4n plus 1, 2, 3. So, you will have 4n plus 3 cycles. Okay. I will leave it as an exercise for you. Develop a formula for the number of clock cycles to do the scan testing of a circuit, of a sequential circuit with n flops and using T tests. So, T is the total number of tests and n is the number of flops. So, you can try and develop your own formula. It may not be such a hard thing, right. So, these are the issues with scan test. We need extra area, we need extra power, we need extra delay, we need extra wiring. That wiring complicates things, it extra area it will also take. Even this may impact the performance of the chip, the extra area. We need extra pins. So, in the early days, I think when it was first proposed, it met with a lot of opposition, right. People were unhappy that a test guy, right, is asking the designer to do all this, right. So, they felt it was like the cart is drawing the horse, how they say. So, usually there is a cart and there is a horse that not good at drawing here. So, the cart is driven by the horse. This looks more like an elephant, sorry. Okay. The but so this is like test and this is like designer. So, the designer designs and the test guy must follow, okay. But here things were getting reversed, okay. The test guy is telling the designer what to do, how to do, etc. So, initially it met with a lot of opposition. They complained about the area penalty, delays, mux, the mux power. Power may not have been a big deal in those days. I think mostly they were complaining about area and maybe delay and all the extra wires that you have to add in and all that, right. But over a period of time, they have realized that there is no other way, okay. You can't really do any other way, right. So, this is what is called as DFT, design for test. So, we have changed the design itself, okay. We have modified the design for the purpose of testing. If you did not do this, then the manufactured circuit will be very hard to test, okay. So, that is the whole point, okay. So, we will stop here and we will continue when we come back, all right, bye bye.